Hi folks, today I bring you another vintage clock integrated circuit from National Semiconductor. This time we are looking at the MM5457N. Since this device is very similar to the MM5455N, I highly recommend watching that previous video first, as it provides a great foundation for understanding this one. Today, we will focus mainly on the differences between the two devices. The first difference, and also the most obvious one, is the package itself. The MM5457N has 22 pins, while the MM5455N has 24 pins. Because the pin count is different, the pin assignments are different as well. For that reason, we must pay close attention to the power supply connections. In particular, we need to correctly identify VSS on pin 4 and VDD on pin 15. Another important difference is the clock reference frequency. The MM5457N supports only 50 Hz as its time base. It is also designed exclusively for the 24-hour format. This configuration is fixed by design. Its close relative, the MM5456N, supports both 50 Hz and 60 Hz operation, but only in the 12-hour format. Like several of the clock circuits we have already analyzed on the channel, this device displays the time using the format 0:00 rather than 00:00. This detail is important because it means that the fourth digit, the tens of hours digit, only needs to represent the numbers 1 and 2. As expected with a display system synchronized to the mains frequency, the camera captures a visible flicker in the segments. This is normal behavior and is a consequence of the way the display is driven. To demonstrate how the segments are controlled through the two electrical phases, I will perform a simple test. First, I will disconnect phase 1. At that point, only the segments controlled by phase 2 will remain illuminated. Then, I will reconnect phase 1 and disconnect phase 2. This leaves only the segments associated with phase 1 illuminated. It is a simple demonstration, but it clearly shows how the display multiplexing method works. Fortunately, the datasheet for the LTC637D1P display is available online. This saves a significant amount of time that would otherwise be spent identifying the display pins manually. Even though the display is a common cathode device, the datasheet is still extremely useful. Once again, I would like to highlight the care taken in the design of both the integrated circuit pinout and the display pinout. Most of the connections line up very conveniently, making the implementation on a printed circuit board much easier. The method shown here can also be used to determine whether a display is common anode or common cathode, while at the same time helping identify the segment pinout. For this test, I used two 330 ohm resistors, one connected to each polarity. After this brief introduction to the MM5457N, bringing one of these vintage clock circuits back to life becomes a very straightforward task.